Hi guys, welcome back. Today we're gonna have some fun with my coil gun. Hoppa! I want to fire this at a bunch of stuff. Bottles, cans, metal sheets, wood sheets, bricks, who knows. But first, before we have some fun, we have to learn something. Because I'm working on the third version of this gun. And there is a bunch of stuff that I want to improve and I want to talk about. Not just that, but already a bunch of you guys made this project, downloaded the Gerber files and assembling the entire gun. But you also had some problems assembling it. So I also want to talk about that and fix those problems. So in this video I want to talk about the CoilGun project because I'm working on the third version and talk about the most common problems that you should encounter when you're assembling this and how to fix that, the future improvements that I want to add, and also some safety features because this is a very dangerous project. Also I want to talk about some comments that you left in the previous video and also have some fun shooting at a bunch of stuff. That being said, let's get started.
PCBWay is creating high-quality PCBs for prototyping and for very low cost, so everyone could use their services. So don't hesitate and for only $5, order your PCBs in just a couple of minutes and improve your projects. I've used their services for years, and the PCBs are just as I wanted them to be. The finished surface is perfect. The solder mask as well. The size, the vias, and the markings are precise. You can select all sorts of settings, starting from the thickness and the color, up to the gold finish for the better conductivity, the copper thickness for more current, and other specific settings. So check PCBWay.com for PCBs and other services, such as CNC metal engraving, 3D printing services, and mold injected parts, so you could make the entire project at the same time. So if you have a good project, why not make it perfect using PCBWay?
What's up my friends, welcome back. I've made this CoilGun project like 1 year ago and the first version was like 2 or maybe 3 years ago, and I haven't posted any update or any improvement because literally I had no time with the movement to the new house and all that. But now I'm working on the third version and I'm fixing it and I want to make it a lot cooler with auto reloading, with a bunch of cool sensors and measuring the speeds. We'll talk about that at the end of the video. But you also have made this gun. A bunch of you guys on the internet share some pictures with me on Patreon. I think that already like 6 or 7 people already made this gun, but you all encountered pretty much the same problems. So I want to address those problems. Why it's not working for you and how to fix that. Okay, so error number 1 that happened to myself as well, happened to me, is not using a proper supply for charging the capacitors. Now remember, you have 10 huge capacitors that needed to be charged at 450 volts. So you have like a 500 watts inverter here that is generating that power. So if you don't have enough current from the batteries, it won't output 450 volts. It will only output like 20 volts. We'll make a test in just a moment. Because for example, my power supply can only output 4 amps. If I connect my power supply to this, it won't be able to charge it. That's why we use lithium-ion batteries or LiPo batteries. So if you are making tests, which is usually what you do when you first assemble it, with a lab power supply with only 4 amps, probably that's the problem, that it won't charge, because it doesn't have enough current. Okay, so now the gun is supplied with my power supply at 12 volts, which is the same that this battery should have. So now if I turn it on, 6 volts, let's just try to charge it. As you can see, I can hear like a buzz, but it's still 6 volts. And as you can see, it's only drawing like 0.6 amps. That's because it doesn't have enough power to supply the entire gun. Let me just increase the current. Now the voltage is the same, but the current is increased to 4 amps. So let's just try it now. Now it is charging, but a lot slower than with batteries. And you can hear like a buzzing sound. And as you can see, the voltage dropped a lot. So imagine that you have some batteries that could not deliver that amount of power. This wouldn't charge. Now it's charged to 400 something volts. We should discharge this to something. Let's just fire it at something. Oh, it hit it right on the edge. Look at that. Guys, I was just preparing for my next shoot because this one hit here in the edge of the can and I want to hit it in the middle. I just realized that the bullet hit my drywall. Now I have a hole. I've placed my previous background because I don't want to damage the wall. So in this, like this, I have some protection. But now, as you can see, the supply is not connected anymore, and now the entire CoilGun is supplied with these 3 batteries. So I'm pouring it on, and now if I flip this switch, as you can see, I'm charging it. 200 volts, 250, 300, till I reach 400 volts. I think it will reach 430 or something like that. Anyway, I should stop it. And now it's fully charged because I have enough current to supply the inverter. Another common problem is to work with it like this, without the cover. And as you can see, I have a bunch of light from the sun here. But remember, this is working with infrared sensors. So if the light from the sun touches these sensors, it will be always active. So even if you are passing something inside of the tube, the sensor is still active because it receives a lot of light. If you put it here, out of the light, it won't be active. So yeah, without having a cover, or maybe insulate only the infrared sensor from the sun, you might have problems because this will be like always open. So you're trying to charge the batteries, but the circuit is always open, so all the power is dissipated inside of the IGBTs. So yeah, make sure that no light from outside of the gun is reaching the sensors. And how could you know if a sensor is active or not? Well, very easy, because the PCB already has something for that. Let me show you. The circuit for each of the coils is the same and repeating itself 10 times. So if I explain for this one, is the same for the other ones. And for each of the packs of the coils, I have one infrared emitter, which is this one, infrared receiver, which is this one, which is a photo transistor, and this LED here of red color. So if the infrared light from the emitter reaches the transistor, so if infrared lights gets here, the circuit is closed, so no current will pass through the coil. But if it doesn't, so we have something inside of the tube, then the coil is activated and power will pass. So the only thing that you should check is that red LED. If the red LED is on, that means that light is not reaching the infrared transistor, and if the LED is off, light is reaching the transistor. So as you can see, if I'm putting away this LED, that LED will turn on, and if I put it back, it will turn off, like that. So the only thing that you should check is that red LED. So make sure that the infrared LEDs are inside of the case, so no external light from the sun will reach inside it, because that could affect the entire circuit. Also make sure that there is nothing in between the LED meter and the infrared receiver, because if that's the case, the light won't reach it, so the circuit won't shoot. And also one problem that I found with you guys when sharing the pictures with me on Patreon is that you place the infrared resistor, the photo transistor, backwards. Now, since this is just like a dark LED, it's very difficult to know which is the emitter and which is the collector. But if you look closely, we have like a flat side on this LED marking the emitter, like the negative side, the side that's going towards ground. So make sure that you place it not backwards, because if you place it backwards, that part of the circuit will never shoot. So yeah, this might be the problem. Not just that, but on the PCB we have the markings for the LEDs, and you have like a plus sign for the positive side, and on this side we have the photo transistor, and you can also see that flat side. So if you just place the LED, I mean the photo transistor, with the flat side on the flat side of the seal clear, you're good to go. As you can see, I had to take it out from the enclosure, so now this is just a prototype, so we could make some tests. Hoppa! Never connect power without checking the wires. There was a short circuit and one CCR blew up. So be careful with that. Okay, by now I think that you should be able to make the project. But I also have some errors that I want to fix for the design, or not just fix, just improve them. For example, my circuit uses SRCs. And this is not a transistor, you can turn it off and on. I mean, once you turn it on, it will turn off when the power is empty, the capacitor is empty. So that means that once you turn it on, it will empty the entire capacitor without turning off. But when the bullet is moving very fast, you want to discharge only power when the bullet is passing inside of the coil. And once it's passed, you want to cut off that power. So one of the improvements for the future version is to, instead of using SCRs, is to use IGBTs. Because with IGBTs you can turn it off and on, and once the LED passed, you can just turn it off, save some power, and also improve the efficiency. And together with the same problem of using IGBTs, I mean the solution of using IGBTs, I should also use 2 sensors for each coil, because one sensor will detect when the bullet is at the input of the coil, and the other will detect when the bullet is at the output of the coil. Because just remember, a coil has magnetic fields on both sides. This magnetic field will attract the bullet, but once the bullet passes the coil, it will attract it in the opposite direction, so it will slow it down. So what we want to do with the IGBTs is once the bullet passes the middle of the coil, cut off the power so there won't be any slowdown, so it could continue to the next IGBTs, to the next coil. And for that we need two sensors, one at the input and one at the output. Okay guys, so yet another improvement for the third version is to also change the size of the coil. And that's very important. And by size I'm not meaning the diameter, maybe the how long it is, but let me explain. The bullet will start accelerate and each time it will have more speed. So by the time it will get like in the middle here, the speed will be a lot faster than here. So that means that the charge that we have stored in the capacitor has to discharge faster and faster. So we need to dump as much power as possible from the capacitor, each time faster. And how could you do that? Well, to make smaller capacitors, or maybe have the same size of capacitor, but to have less resistance. So by making less loops inside of the coil, we increase the amount of current, and by that we decrease the time that it will take to discharge. So by making the coil smaller and smaller, so less and less loops, and also shorter and shorter, we ensure that by the time that the bullet will get towards the tip, each time it will accelerate faster and faster, and the charge from the capacitor will discharge faster. So as you can see, now I have all the coils the same size, and that's not okay. So what I should do is to make the coils smaller and smaller, and that's another improvement. And one more thing I want to add is a speed meter. So that should be very easy, just add an Arduino, and we should measure the speed between the last two sensors. Because if you measure the speed between the first sensor and the last one, is not the same because the bullet is constantly accelerating. So to get the final speed, you should measure the distance between the last two sensors and the time it took the bullet to enter and output from the coil. And by knowing the distance and the time it took to make that distance, you can get the speed. And that's very easy with an Arduino or an ESP32, and maybe add the screen and show the speed each time that you shoot it. So yeah, these are some of the improvements that I want to make. Obviously I want to change the entire case and also add auto reloading, so I have all the bullets inside, and with the servo add the next bullet, and each bullet should be held in place with a small magnet just at the tip of the entry of the tube. Maybe change the tube from plastic, because I've already changed it from metal to plastic, which is a lot better, and maybe change it from this type of PVC to carbon fiber. It should also work, and a bunch of other smaller things to the case to improve the project and make it cooler. So maybe by the time that I'm posting this video, I will already have the PCB for the third project, the third version. You can still download this from below for free. As always, I'm sharing my files for free if you want to make this project, or maybe just wait a month or a month and a half till I will finish this, because I have to receive the new PCB, I have to finish the design, order it, make the project, test if it works, and if it works, then I will make the video, record it, edit it, and post it. So it will take some time, as all of my projects. But anyway, other improvement that I want to add, some small improvements, is to add the voltage screen for all of the phases, all of the stages of the coils, because right now this measurement here, this multimeter, is measuring only the voltage on the first capacitor, and you have to guess that the other capacitors are charging to the same voltage. But no, since we have diodes in between, the current, the voltage is not connected to this multimeter, so I add a small meter to each of the phases, each of the stages, so you should know the voltage on each stage. Other improvements that I want to make is to change the battery and add a charging system, because right now the battery is held here in place, is glued in place. It was placed with some Velcro which fell away, but I want to add a bigger case here with the LiPo battery inside, because LiPo could discharge more current than this Li-ion battery. So it will also have some sort of USB input, so I could charge the battery without taking it out, and add some lights and maybe even a cooling fan to cool the inverter. And those are some of the improvements that I want to make. And since I will already have an Arduino on our ESP32 inside with a screen to show the speed, I could also change the reloading speed, and maybe how do you want to reload, and maybe burst action, or how to activate the charging or discharging instead of buttons like this, to just use the Arduino to control that, to charge it or discharge it, and when the battery is low, to cut off the power, and so on. Because once you have an Arduino or a microcontroller, you can make all these kinds of processes. Now that we have talked about the problems that I have and how I will improve the PCB, and share with you the schematic and everything for free as always, we're ready for some tests. So let's shoot something. By the way, this is what I'm using to shoot some small metal bars with the same diameter as my tube, but also some small bolts like this one. But I've seen that since this has a little bit more mass and a little bit more length, it will accelerate a lot faster. I'm also planning to sharpen the tip, maybe. And yeah, the more you sharpen this, the more it will get more dangerous. So once again, if you're not sure to make this project, don't try this at home. Just with the high voltage is already dangerous enough. If you add bullets and projectile and high speed, it's a lot more dangerous. That's why I do it, so you don't have to. Okay, so in previous videos, I've only shoot it through some plywood, which is not that great, it's not that fun. So now let's just start directly with a tin can like this one. And this is very thick, it's not like a Coca-Cola can, which will also shoot. This is a lot thicker. So let's just start with this. I have the other camera and I really hope the bullet won't bounce and hit my camera because it costs a lot. So let's just charge it and shoot. So guys, I break it. I was making tests, something started beeping, I think a transistor was loose. I tried to change one of the photo transistor and just touch the tube and melt it, so now the bullet cannot pass. So I had to take everything out, regular case. I don't care about the case because I wanted to make a new one, but I really need this tube and I don't have another one. And I don't have to change it to the metal one. Don't know what to do. So guys, I blew it. I mean, I'm fixing it, so stay tuned for that. And this is why it's better to have it segmented, because if you fail something inside of the entire gun, with this you have to change it everything, or everything will get blown. In this case, I was changing this SCR, and I've made a short circuit, and now all the transistors, these small transistors, they are burned out. So as you can see, if I'm starting it, there are a bunch of LEDs that are always on without even having the tube inside. So if I just place something in between, it won't work. But now I'm changing this, so and since the PCB is very small, I've hooked this up with some wires, and then I'm adding the BJT transistor like this just to make the test, because it's very difficult to now to unsolder it from below and then solder a new one. But if you had it with segments, you can just take one segment out, fix it, or maybe just place another in, and that's it. So yeah, now I have to fix all the BJT transistors and then make the test. It finally works, so yeah, we'll make the tests. But as you can see now, it's quite ugly with all the BJTs like this. These are all the components that I removed, even a CCR and even an LED. And that also teach me something for the next version of the PCB. For example, if I'm using through hole components like this one, place the pins a lot more far away so I could solder them. Otherwise, without having access below, it's very difficult to solder such components or desolder them and change them. Also, I'm also thinking to make another modular version, but make it a lot stiffer, because that was the problem with the segmented PCB like this one, that there is not a good connection between one segment and the other, so they could break. So maybe change that and maybe add like a rod that will keep the PCB in place. And yeah, so yeah, we'll rethink all the components and the position, so it will be a lot easier to solder. Guys, you can clearly see that it passed right away, and this is quite thick. God damn, that's a huge amount of power. And the problem right now is that since I burned out the voltmeter, I'm not sure what voltage I'm charging it to. So maybe it was 400, maybe 300 and something. Yeah, it's difficult to know, but we'll get that. Okay, so let's shoot again, but this time I've made the tip pointy, which is double the danger. So please, don't make this if you're not sure about the project. So yeah, let's shoot it once again. Okay, so as you can see, even with the pointy bullet, the hole is still sideways. So I'm guessing that since the bullet has no rotation, it will flip in the air sideways and then hit. So, I mean, in a professional weapon, inside of the barrel we have grooves that gives the bullet spin, so it won't play sideways. And obviously we don't have that, it's very difficult to add that. So yeah, it was pretty cool. It sounds very, very hard when it hits the tin can, but without that, the gun makes no sound, just a click. Okay, so now let's shoot at a brick. Now this is a triple wall brick and it's 10 centimeter width. I'll place it like this. So I'm not sure if I will break it, but it will be cool to break it. Well, that was a bit lame. I will try to place the more or less high-speed footage. But yeah, it made just a hole. It wouldn't crack. I also found the bullet here. So yeah, it did not break. So maybe just shoot another time, maybe close to this. And since now this is weakened because of the hole, maybe it will blow up. But yeah, it was a little bit lame. So guys, I've shot it 2 times, but at the second time, as you can see, it made a hole and it passed inside of the brick. We have the bullet there. That's crazy. I thought it would break the entire brick, but I think it's pretty compact and it just passed through. Yeah, that's pretty cool. I mean, just one layer, obviously, right? Yeah, we'll put it there. There you have it. I will try a filled can in just a moment, but now let's just test it with this kind of ceramic. As you can see, just a board. And I think it will break this one, because if it made a hole in a brick, since this has no support behind, I think it will break it. Let's just test it. Okay, now let's shoot at the can. The problem right now is to aim it exactly towards the can, because since it's quite small, I hope it won't shoot on the side of it. And I hope that it won't get wet my camera, or maybe it will bounce towards my camera. I hope that won't happen. Yeah, let's just charge it and shoot at it. What? I had to clean everything out. Look at that. Now my entire workshop will smell like lemon beer. But as you can see, we have an input and an output. That was crazy. Now I would like to shoot, for example, at glass, but it will make a mess here in my workshop. Not just that, but I lost the pointy bullet. I can't find it anywhere. So right now I've made some tests with this, which is actually from a screwdriver, and it works quite well. And not just that, I can take it outside to shoot at stuff that are messy, because right now, since just like a prototype, is hooked up to my supply, and I have all these wires. So what I will do is to hook it to my oscilloscope and measure the speed between the last two sensors. Okay, so I have it hooked between the last two sensors. Actually, to get the real speed, it should be between the last one and at the output of the last one, but I don't have one. Anyway, in this case, it will be between these two here. Hook it to the oscilloscope in single mode, so it will jump when it will create a pulse. By measuring the distance between these two sensors and the time, we can get a speed. Let's just do that. Alright. Okay, so I have the time between the pulses. This is the first pulse and this is the second pulse, so we have a difference of 1.225 milliseconds. Now let's measure the distance on the PCB, and with that we can... And the distance between the sensors is 4.7 centimeters. So let's just... Using this online calculator, 47 millimeters and a time of 0.001225 seconds, which is milliseconds, we get 138 kilometers per hour. We can even change it to meters per second, which is 38, and kilometers per hour is 138. Have in mind that any firearm will be above 1200 kilometers per hour, so this is nothing close to a firearm, but I think I could improve it in the third version. So keep in mind this number for the third version to compare it. There are a bunch of parts failing with this prototype, and I know that because the speed is not that high, and I made some tests with the previous version, and the version before had higher speed, not much higher, but higher than this. First of all, I had to change once again the tube from plastic to metal, which is not great. That's because while soldering the components, I've melted this one and I only had one. So once again, I'm using the metal tube, and remember, the metal tube is also moving with the magnetic fields. And as you can see, we have a few LEDs that are right now on, and that means that the entire tube moved forward a little bit and turn off the LEDs. And that might happen during the fire event. So that means that by the time the bullet gets to the last coil, it will slow down because it will shoot before before the bullet is in the correct position. Also remember that the metal tube is creating a lot of friction compared with this one. So once again, that's also slowing down. And I think some of the circuits in the middle, even if I change the transistors, is failing. Meaning it's not firing at all, and it will only dissipate power. So I can't know for sure right now because I have to make a lot of tests, but I have that impression because some of the LEDs of the charging capacitors, even if after I shoot it, it will still be on, meaning that the capacitor is still a little bit charged. Not fully charged, but it still has power in it, so something is failing right there. So yeah, stay tuned for the third version because I'll improve it a lot. So guys, remember, if you want to replicate this project, please have in mind that it's quite dangerous. For one side, the electronic part is working with high voltage, and the second part, physically it could damage you because it shoots projectiles. So please, if you're not sure about anything and if you don't have proper insulation or you can stay aside of the gun, please don't make this project. But if you want, you have my Gerber's files for free below as always, and all the schematics, the components that I'm using, everything that I'm sharing as always is for free. So check the description if you want to make the same project, download the Gerber files, go to PCBWay, order the PCB and make it. Also stay tuned for the third version with a lot of improvements. So guys, I hope that you have learned something new because I did. I'll fix all my errors. For sure it will have new errors, but I will fix those in the future version and so on. That's what making projects is. And if you learned something new, comment below, give a like, share this video. That will push my channel a lot. Thank you for that. And keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it. And the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.